Hello everyone, data structures, algorithms. Today we will talk about the cell sort. The cell sort is an algorithm and it improves the efficiency of other algorithms like the insertion sort or the bubble sort. We have already seen this in this course, both of them, insertion sort and the bubble sort. What it does, it cuts down the amount of shifting of the elements. If most of the values are already sorted, insertion sort, for example, runs in almost linear time big O to the n. It is also an in-place algorithm and an unstable algorithm. Let's take as an example here the insertion sort. The insertion sort chooses which element to insert using the gap of 1. If you can remember, we had the sorted part and the unsorted part, and then we use the gap of 1, so we compared the first and the second values, and then the second and the third, and so on. The cell sort starts using a larger gap value, for example 2, 3, 4, 5, and so on. As the algorithm runs, the gap is reduced. For example, if you have the gap of 10, then you can reduce it, you can cut it down to 5 and then cut it down to 2 and so on. The goal is to reduce the amount of shifting required. We do some preliminary work, and by the time we get to the insertion sort, the array has been partially sorted. That means that less shifting is required. Depending on what gap we are using, the time complexity is different. Commonly, a gap that is used is the Knuth sequence. The Knuth sequence, with using the Knuth sequence, you can find the gap, and it has a formula of 3 to the k minus 1, and the result of that you can divide it by 2. So you can have in your mind if the gap that will be used will be the following. If you have an array close to these numbers, to the numbers of the right side, then you can use the number of the k. The value of the k will be the number of the left side. For example, if you have an array of 4 elements, then you will take the value of 2 for the k. So you have 3 to the 2 minus 1 and then divide it with 2. If you have an array of 3, is also close to the 4, so you will also take the k, the value for the k will be 2. If you have an array with 13 elements, you will take the value of 3. If you have an array of 20 elements, it's up to you to decide, but you can take either 3 or 4 and so on. Now we can also see an example. For example, we have an array of 6 elements. We will take the gap value of 5. Then we will reduce it by 2. We will divide it by 2, and then again and again until the value hits, the gap value hits 1, and then we will do insertion sort. For example, we have this array 18, 42, minus 8, 4, 60, minus 77, and if you can remember from the insertion sort algorithm, we did sort the whole array and then we had to sort it again from the start until the end, because the minus 77 was at the end of the array. And this is the part where the cell sort will help us. We will take the gap of 5. That means that we start comparing the 0 element with the number 5. The number 5, remember, we start counting in arrays from 0, is the last element. So we swap, because the minus 77 is smaller as the 18, and then we compare the first element with the fourth, and then the second element with the third element, and so on. But then we continue with the insertion sort. It might seem like nothing, but it's actually a really big deal. The minus 77 is also all of a sudden at its correct position. And then we will do insertion sort like we saw in our previous video, and we rise and repeat until the array that we have is sorted. But remember, The minus 77, which was the hardest part, was already solved because it was already in its correct position. So the time that this algorithm needed was being significantly reduced, and this is how this cell sort algorithm works. Now we can write some code. You can open up your Eclipse, IntelliJ, JetBeans, Notepad, etc., and the code implementation will be at our next video.